Hello, ladies and gentlemen. This is Mr. Heron, and this is Trig for Unit 3, Lesson 3, Applications of Using the Law of Sines and Cosines. So, remember, law of sines, you're looking for that side and angle relationship, and you're trying to use that as much as you can. Cosine is when you have either three sides or a side angle side situation where you don't quite have that side and the opposite angle. So what you're going to do is look at some word problems and see if we can figure out, using sine and cosine, how we can solve that. So take a look here at the first problem. And what you're trying to do is kind of these ideas. Reading the problem, study or draw a picture, figure out what kind of triangle you're dealing with, and then trying to solve from there. So, using the law of sines, law of cosines, or sometimes a combination of both. All right, so let's take a look here. A pilot is flying over a straight highway. He determines the angles of depression to 2 mile posts 8 miles apart to be 30 and 46 degrees. Find the distance of the plane to point A and find the elevation of the plane. So find the distance of the plane to point A and find the elevation of the plane. So first off, distance of the plane to point A means I need to actually try and determine this length right here, okay? And then to figure out the elevation is figuring out this right here. Okay, that would be the elevation of the plane. All right, so that's kind of what I'm looking for. So what I want to start with is this. Okay, if I've got 46 here, then that means this is going to be 46 here. If this is 30, that means this is going to be 30. So 180 minus 46 minus 30 gives me, I think it's 104. So it gives me this angle is 104. All right, so now to figure out this length, the distance to A, which is what I'm solving, here's what I would do. I would start with, the sine of 104 over 8 miles. That's going to be equal to the sine of 30 over, we'll just call it, little b. Okay, so taking the sine of 104 over 8 equals the sine of 30 over this length right here, which I'm calling b, which I also want because that is just going to be the distance from A to the plane. So I'm taking 8 times the sine of 30. That's going to be equal to b times the sine of 104. So a little bit of division. Cancels out. So I want 8 times the sine of 30 divided by the sine of 104. So I get that length to be 4.122. So it is a direct length of 4.122, and we're talking about miles for that problem. So now I'm going to use this, and I'm going to figure out what my actual height is here. Okay, so I know that this is 4.122. So what I've got is a triangle where this is 4.122. I know that this is 46, and I'm looking for that height. So now this is just old school SOHCAHTOA stuff. All right, so I'm just going to take the sine of 46. That's going to be equal to h over 4.122. And I'm just going to multiply both sides by that. So sine of 46 times 4.122, and I get 2.965. That's going to be my answer. So my height, my straight vertical height, is at almost 3 miles in the air. And the distance from A is going to be 4.122 miles. All right, so okay, that one wasn't bad. Let's talk a little bit here about what a bearing is. A bearing is an acute angle, so less than 90, measurement from due north or due south. All right, so this would be north 30 degrees east. This would be north 60 degrees west, south 70 degrees west, south 50 degrees east. Please notice everything is stemming from that vertical north-south line. All right, so now having that in mind, we're going to do a little problem here. And a lot of this is going to be in the setup. So let's start with this. Pilot flies out of an airport and heads in the direction north 20 degrees east, flying at 200 miles an hour. After 1 hour, he makes a course correction and heads in the direction of north 40 degrees east. Half an hour after that, he has to land. So let's kind of set up what that might look like. So the airplane takes off north 20 degrees east. So he's going north 20 degrees east. So this is 20 degrees right here. He flies for 1 hour. So this distance right here is going to be 200 miles. All right, then once he flies for that hour, he's got to make a course correction. Now he's going north 40 degrees east. And he does that for half an hour. So half an hour, so if he's going 200 miles an hour, so for a half an hour, that means he's only going to go 100 miles. Okay, so as I look, he's gone 200 miles and then 100 miles. And then after that, he's forced to land. So we've got this little triangle here where I know two of the lengths, and I can figure out some of the other pieces here. So what do they want to know? They want to know, find the distance between the airport and his finding landing spot. So they want to know how far is it from here to here. All right, well, let's play the angle game. Let me clean this up a little bit. So what we've got is this. So this is 20 degrees, this is 40 degrees. So if this is 40, that makes this angle in here. Let me zoom in and make this a lot easier. All right, so if that's 40, that's going to be 50. This is going to be 90. And if this is 20 degrees, that makes this 20 degrees. So after all that, this whole angle is going to be 160 degrees. Okay, and that's because this is 20. I really hope you guys draw a straighter line than I did. So that makes that 20. This angle up here is 40. That makes this 50. And 90 is still 90. All right, so this angle is 160 degrees. Okay, so if I just draw this out, here's what I've got. If I take away some of the other stuff and just kind of clean up my triangle, here's what I've got. I've got a side of 200. Got a side of 100. Got an angle of 160 degrees. And I got to figure out that. So what this is kind of screaming for is law of cosines. So that's what I'm going to do. I'm looking for this distance squared. That's going to be equal to 200 squared plus 100 squared minus 2 times 100 times 200 times the cosine of 160. Okay, now how did I do that? Well, where did I get 160? Well, let's take a look here. From the original starting position, the pilot takes off, and this is 20 degrees. All right, which makes this 70 degrees. But that doesn't really help us very much. What does help us is this fact right here. When he has to reset the course, we figured out that this is 20 degrees. That makes that 20 degrees. Then when the pilot resets the course and goes at 40 degrees, I need to make this 50 degrees because that's still 90 degrees. So I've got 20 here, 50 here, 90 here. That's where I get the 160 from. Okay, 20, 90, and 50 are going to give me 160. Now it's just some button mashing in the calculator to kind of figure this out. And I can get away with putting all this in the calculator at once to a degree. So d squared equals 87,587.704. So if I square root that, so my distance is a little over 295, not quite 296 miles. All right, so 295.952 miles. All right, so all I did, figure out this angle, and then it became a law of cosine situation. All right. So here, find the bearing from the airport to the final landing point. So I have this is 20 degrees. I have to figure out this length. Okay. So we already figured out on the previous spot that this is 295.952. Okay, we are trying to figure out this length right here. Well, now this is nothing more than just law of sines. So we know that this is 160. So I'm going to take the sine of 160 over 295.952. And that's going to be equal to the sine of x, which is what I'm looking for, over 100 miles. All right, because this angle is across from that 100-mile loop. So 100 times the sine of 160 over 295.952, that will equal the sine of x. .952. So when I take sine inverse of that, if I take sine inverse of all of this, I get 6.636. Now, remember, that is just this little angle. Okay, I want to know the full heading. All right, so all I'm going to do is I'm going to take my answer and I'm going to add 20 to it. So my final answer will be north 26.636 degrees east. That would be the heading I would need to go on to fly directly to that plane in a straight line. Okay, the old famous truck one. Two trucks leave the same city at the same time. One truck travels 50 miles an hour in the direction north 50 degrees east. The other truck travels at a speed of 70 miles an hour at the direction of south 60 degrees east. How far apart are the two trucks after 1 hour? So they both drive certain speeds, and it's after 1 hour. So the first truck travels 50 miles, second truck travels 70 miles. So let's kind of look at what I'm dealing with here. So one truck travels 50 miles an hour at north 50 degrees east. So that's 50 degrees there. The other truck travels where that is 70 degrees, and he has gone, 60 degrees, sorry. 60 degrees, 70 miles. So that's 60 degrees, this is 70 miles. The top one, that's 50 degrees, and that's 50 miles. So what they want to know is this distance right here. So if this is 50 and this is 60, this whole thing still has to make a line. So that whole thing has got to be 180. I'm going to subtract 50 and subtract 60. And I'm going to figure out that this is 70 degrees, this whole angle right here. Now I'm trying to figure this out. I'm trying to figure out, we'll call it C. Well, I've got a side angle side situation here. All right, I've got a side angle side situation. So I'm going to go law of cosines on it. So what I'm going to say is this. I'm going to say, okay, C squared is going to be equal to 50 squared plus 70 squared minus double those things times the cosine of 70. All right. So another way you could have figured out the angle measure is this way. If this is 60, this is 60. If this is 50, this angle is 50. It's still a triangle. It has to add up to 180. I could have gotten 70 degrees that way. Now, again, everything's on one side, so I can just do some button mashing and let the calculator do the legwork for me. So then when I figure that out, I get C to be equal to 70.752 miles. So after an hour, they are only a little bit more than 70 miles apart. All right, so that's all I'm doing, playing around with that. A lot of this is in the setup, so you might have to read or reread the problem and take a look and double check and make sure that your picture actually reflects what the problem is saying. All right, so you can hit pause, go back and rewatch this. So use law of sines and law of cosines to solve word problems. There is your assignment, page 506 and page 514. See what you can do with those, and then I will answer any and all questions on Wednesday. Thank you.